So in this video, we are going to review transformations. So you should remember how transformations work. We did take notes on them. You could probably find a note sheet in Notability that you have worked on about transformations. But I'd like to do a few from each section, and there's one, I think, down below that you need to do a little edit for me. But first, let's just start with each section. Let's look at 1 through 6. Now, in 1 through 6, it says to describe in words the transformations that are performed on f of x equals x squared to obtain g of x. So let's just do number 3 and number 6. So think about working your way from the inside of the function out. If we add on the function, remember that's going to move it left. So this function you would say has gone left 3. And if you add a negative on the outside, it's like you're subtracting. We could rewrite this function to look like x plus 3 squared minus 7. So that tells us this function has gone down 7. So the first 6 problems just given me in words what has happened. And I'd like to do 6, and then we'll jump to the next section. So for 6, it says g of x is 1/2 x squared minus 5. Now the first thing that touches anything is that 1/2. What this does is it cuts the height in half. Now you can say just what I did. You could write down, it cuts the height in half. The height is now half as tall. It actually compresses it, and it compresses it downward. So it is half the height. And then the next thing that touches it, like we had a subtraction of 7 here, we have a subtraction of 5. That is going to move the function down 5. So that's all you want to do for this little problems 1 through 6. What happens to the function, okay? And if you're stuck about what's happening, feel free to throw it into Desmos, take a look at it, but I want the description in words. Okay. Now let's look at 7 through 14. We are given an equation, and then we are given some graphs, okay? Now, the first thing I would do if I were the student doing this is 7 and 8 are both quadratics. They're both parabolas. So one of them has to be A, and one of them has to be F. So just look, what happened to the function? Did it move left? Did it move right? Did it move up? And did it move down? Okay. 9 and 10 are absolute values. They're going to be V's. Remember our parent function V's. So one of them is going to be B, one of them is going to be E. Which is which? 11 and 12 are both cubes. Cubes are going to look like either C or G. One of those has to be C and one of them G. And then 13 and 14 are both square roots, D and H. Okay. Now, for 15 and 29, I want you to graph those, but I want you to skip a few for me. That's the edits I was talking about. Please do not do, so actually let's do it like this. 17, 21 are bonus. So if you want to do 17 and 21 for bonus, please do so. Please, 26, could you please make those are actually called a step function. Don't make those a step function. Instead, could you just make them absolute value bars for number 26? Remember, 17 and 21 are bonus. Now, please, in Notability, if you hit the circle with 3 dots on it, and then you hit template settings, one of the ones is a grid. Please apply that, and that will be on the blank sheet of paper. We're going to need that. So I expect to see accuracy to at least a minimum of 3 points. I want all of the graphs done 15 through 29, using what we know about parent functions and transformations. Please graph 15 through 29 by hand, okay? Now, I would like to talk about 30. It says to draw a separate graph on the graph paper for each transformation. So I'm just going to do 30A and then hopefully it will lead you as to what happens for the rest of them. E is bonus. Okay, let's talk about 30A. We know, hopefully, that if we were to put a negative on the outside of a function, it should flip it over the x-axis. So when you're graphing this, in this paper, graph paper is pretty darn big, so I'm going to kind of cut those in half just to make it kind of fit a little easier. Take the bumps, important points. Okay. So we have a point at negative 7, 0. The zeros are going to stay. So that's going to be a point of rotation. Another point is 1, 0. That's going to be a point of rotation. And then it looks to me like it's somewhere between, almost exactly between 4 and 5. Okay. Now, if we flip over the x-axis, this graph, this little point that's pointing upward, so it will be at negative 4 instead of going upward to 5, it needs to go to negative 4, negative 5. So let's go to our graph paper. Let's find the point negative 4 and then go down negative 5. Okay? So you can now easily connect those points. And my point that was pointing upward is going to go downward. My graph that is pointing downward is going to go upward. So it's still going to be at 3, but now it's going to be at positive 2. So go over to your graph and make your y negative. So 1, 2, 3, up 2. Make that v. And then that point 7, 3 is going to drop down to 7, negative 3. 1, 2, 3, 4, 5, 6, 7, negative 3. So I expect for 30 that I should have a B, C, D, and if you want some bonus points, E graph, one graph for each of those. So that is your assignment that is due by January 3rd at midnight. Thank you so much. Hope you have a good new year.